Let's say we're given a sequence that looks like this. 3, 6, 11, 18. And we're asked to give the algebraic expression describing this sequence. We don't know if it's linear, non-linear. We don't know if it's non-linear, if it's going to be the nth term squared, if it's going to be cubed. We need to find some type of pattern first, right? Plus 3. Oh, I said I wasn't going to add the pluses anymore. Here the difference is 5. Here the difference is 7. Oh. Do you see it already? This is a difference of plus 2. This is a difference of plus 2. Now remember our n squared sequence that looked like this. This also had, these were the terms. We looked at the differences. They were not the same, but the difference between the differences, they all were the same. And that was our pattern in our squared sequence, n squared. Now, do you see how this is the same? We have no pattern, or no, we do have a pattern. With the differences between the terms are not the same, but the differences between the differences are the same. They're 2, just like they were 2 down here. Now this looks a lot like n squared, right? So we know that our algebraic expression is going to have n squared in it. Now let's rewrite it. If n squared was all it was, then our terms would be 1, 4, 9, 16, right? They're not though. They're 3, 6, 11, 18. Can I write that up here? Yes. 3, 6, 11, 18. Okay, sorry for making a mess. So now we know it's not going to be n squared. That's not going to be all, right? This is n squared. This is our sequence that we're dealing with. Here, the first term, our sequence is 2 more than the n squared sequence. Here, our term 6 is 2 more than the n squared sequence. Here, 2 more. Here, we have 2 more than the original n squared sequence. So what do you think our algebraic expression is going to look like? It's going to be n squared, but we're going to add 2 to each term. That will give us our sequence. Done. We can check it. Our first term would be 1 squared plus 2, which equals 1 plus 2 is 3. Our second term should be 2 squared plus 2, which equals 4 plus 2 is 6. Our third term would be 3 squared plus 2, which is 9, plus 2 is 11. 3, 6, 11. Our sequence that we started with, 3, 6, 11. So yeah, this should be right. We could do another example. Let's say we're given this sequence. Let's do this one. 2, 16, 54, 128, 250. All right. It's not linear, is it? 14. The difference here is 38. The difference here is 74. difference here is 122. Okay, so it's not linear because these differences aren't the same. Let's see if on this second layer, so the difference between the differences, let's see if those are the same. 4, 2, 24. Here, 36. 48. Okay, these are not the same. So it doesn't look like our n squared type of sequence, right? Let's see if we add another layer, find the differences between the differences, see what happens here. The difference here is 12, the difference here is 12. Oh, that makes me feel good. That reminds me of here, our n cubed sequence. See, n cubed. We found the differences. They were not the same. We found the differences between the differences. Nope, still not the same. Then we found the differences between those differences, and they were the same. They were 6. Here there are 12. Let's see what kind of effect that has. So we're going to go with our n cubed, right? We're going to say, okay, it's going to include n cubed somehow, but we're not sure what else. Let's rewrite our sequence. 128, 250, right? Our sequence. And then we're going to write the sequence n cubed. And off the top of my head, it's this. So the difference between our sequence and the original n cubed sequence is ours is 1 more in this case. Here ours is 8 more. Here ours is 27 more. Here ours is 64 more than the original n cubed sequence. Here our number is 125 times, 125 more than the original n cubed sequence. All right, let's see what that means. We're totally adding the value of the n cubed sequence, right? So how do we write that? Yeah, we can. So what we're actually adding is the n cubed sequence itself, right? So add the n cubed sequence itself. Now we can simplify n cubed plus n cubed, right? They are like terms, so we can collect them, put them together. We'll have 2 of them, 2 n cubed. And because we feel a little insecure about that, let's test it. Let's find the first 5 terms. If this were the correct algebraic expression, the first term should be 2 times 1 cubed, which equals 2 times 1, which is 2. So far, so good. Second term should be 2 times 2 cubed equals 2 times, this is 8. 2 times 8 is 16. The third term should be 2 times 3 cubed, which is 2 times, what's 3 cubed? 3 times 3 times 3 is 27. And that's 52. 54. Our fourth term should be 2 times 4 cubed, which is 2 times 4 cubed. 4 times 4 is 16 times 4 is 64. 2 times 64 is 128. Okay, let's forget the fifth term because now we feel pretty good about ourselves. 2, 16, 54, 128. Right? So apparently we did a good job. This is it.